Now let's talk about bidirectional RNNs. So we can imagine, let's say you've got a sentence, you're trying to predict parts of speech for each word. So you might have something like, I went to the store, and our Y's for this would be something like pronoun, verb, preposition, article, noun. Let's say we have something like this. And so what we would be doing is, let's say as our sequence, we feed in I, ask it to come out with the type. So X1 would be the word I, or rather the index into the dictionary, and Y hat sub 1 would be a softmax across all the different types of speech, the parts of speech. And then for X2, we'd fit in went, and X3, we'd fit in to, and X4, we'd fit in the, and X5, we'd fit in store. And we'd be training it to do this. Some words, so let's look at another possibility. So I gave the orange. So we have I gave the orange. And again, we want to be coming up with the parts of speech. So we have pronoun, verb, article, and the question is, what's orange? Is orange a noun? Like I gave the orange to the monkey? Then that'd be a noun. What if it's I gave the orange ball to the monkey? Well, then orange is an adjective. So as we're going through from the front, we don't really know, is this an adjective? Is this a noun? We don't know. What we'd really like to know is, what's the next word? So a bidirectional RNN says, you know what, let's just go ahead and feed through our input from front to back, as we normally do. But let's also feed it through back to front, because there may be some useful information coming that direction too. And that's what we're going to look at. One note about a bidirectional RNN, it does not work for real-time information. So if you are trying to, Alexa, trying to respond to human speech, then you need to decide what the human has said as soon as they have said it, and not wait until what they might say in the future. So you can't wait until they've talked for 10 minutes and look and see, and then go backwards and say, now I can finally figure out what they meant 5 minutes ago. You need to decide right now. And so there, we really can only go in the forward direction. So let's look at how this works. We've got normally X sub 1 coming in and creating an H sub 1 and then outputting a Y hat sub 1. And this goes through until we finally have X sub n going through to help create an H sub n and outputting a Y hat sub n. And this is simplified because we're not showing the weight matrices. We're just showing the fact that we have some inputs, we have some hidden values, and we have some outputs. I am going to go ahead and modify this a little bit, and I'm going to put arrows on these. So right arrows on the H's and the Y hats. So we feed these in, X1 to Xn, we get out these values. What we can do as well is have basically a second RNN. So the second RNN is going to have separate weight, and we're going to feed in X sub n and obtain an H sub n, and that'll give us a Y hat sub n. And then we're going to go feed in next X sub n minus 1, and that'll give us an H sub n minus 1. And our output there will be a Y hat in minus 1. We're going to, however, note that these are different H's. So instead of being H rights, these are H lefts. The X's are identical, so this X sub n is the same as this X sub n. The difference is the order we're feeding it in. In the bottom case, we're feeding them in left to right. In the top case, we're feeding them in right to left. And so we end up with, finally, H sub 1 which x sub 1 feeds into, and h sub 1 produces y hat sub 1. And again, these are left, 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 and left. And this would feed out an h sub 0. Why would we care about this? Because if we have actually sequences that we're using within a longer sequence, so subsequences like truncated backpropagation, then we may need to feed this into what was the previous sequence. Okay, go through here. But in any case, so what we notice is we feed in our x sub 1 through x sub n. And what we get as output is y hat 1 through y hat n. We have the right versions going from front to back, and then we also have y hat 1 through y hat n and the left versions. Because our outputs include both these y hats and these y hats. And notice these y hats can compute different things, right? For instance, in this example, the y hat coming out for y hats of 1, 2, 3, 4 might be adjective high and noun high. It knows it's not a preposition. It knows it's not a verb, right? And this is because of all its previous training, right? The previous training has learned that the word orange is never a preposition and never a verb, okay? Never an article. But it is sometimes an adjective and sometimes a noun. And so from the previous, so it knows it's an adjective and a noun, but doesn't know anything more than that. So that's what we'd have in the front to back calculation. In the back to front calculation, on the other hand, we would have the remaining words. So I gave the orange to the monkey. So as we're going backwards, we'd be keeping track, and we'd somehow keep track of the fact that we had seen the word a preposition. So we're going to first look at monkey, and then we're going to look at the, and then we're going to look at to. We're keeping all that history that we've seen, monkey and the and to, and now we get to orange. And now we can use the information that the previous word was not a noun. If the previous word had been a noun, orange must have been an adjective. Since it's not a noun, orange must be a noun. So our y hat in one direction is saying, I don't know whether it's an adjective or a noun. In the other direction is saying, I know it's a noun. And that's what the bidirectional RNN really gives us. So we could feed both of these y hat into a loss function. Or what we could do is take the y hats and we might just sum them together and just get a single, y sub I equals y hat sub I equals y hat sub I left plus y hat sub I right. That's another possibility what we could do. Right, sum them together, or we could just do some sort of a function of these two. Or just feed them directly into our loss function. However, makes sense to do. For this particular example, we would probably have some function that we apply to these. So maybe what we would do is these are the probabilities. Each of these is a softmax probability. We might go ahead and sum together a softmax probability and then rescale so that the totals are 1. So that the right-going one for this one says, it's 50% an adjective and 50% a noun. The left-going one says it's 100% a noun. And then we would sum them together and rescale. So we would have, let's say the right-going one would say, so the right-going one is saying 50% adjective, 50% noun. The left-going one is saying 100% noun. So then what we might do, again, is sum them together. So we have 50 and 150, and then rescale so that our totals, so this is percentages, 50%, 50%, 100%. And now we would go ahead and rescale these down to, what would it be, 25%, 75%? And we'd be comparing against, so these are the y hat values. Right, 25% that is an adjective, 75% that's a noun, 0% that is anything else. And our actual value is it's 100% a noun. So that's how we combine these together in the bidirectional RNN. As far as the training, we would just treat these as two separate RNNs. So as far as the back propagation, we would go through an entire sequence front to back and back to front, and then we would back propagate in the forward, the right arrow case, we're back propagating this way. And in the left arrow case, we're back propagating this way. We always will back propagate in the opposite direction of the forward pass, because our forward pass here was going from left to right. Our forward pass here was going from right to left. That's really bidirectional RNNs. Most libraries will allow you to specify, I want a bidirectional RNN in this particular case. And so we'll just arrange things to create 2 RNNs and go through backwards and forwards, and your outputs then you'll have twice as many outputs. You also, of course, have twice as many H's. So your H is going to be a combination as your output of an H sub n, right arrow, and an H sub 0, left arrow.